right, we're back at our Wednesday lessons. Today we're going to look at sine and cosine graphs. We're going to learn how to graph sine and cosine graphs, and then look at how the graph changes when we have amplitude change or stretch or compression, or also D values are our up and down movement. So, graphing periodic functions. This is a basic step-by-step instruction. So, draw your y-axis, -1 to 1, or whatever your amplitude is. So if your amplitude is 2 or 3, then make sure your y-axis shows that. We want to then label the important periods on the x-axis, and right now we're focusing on a period of 2 pi. And so you're going to put on the x-axis out here at 2 pi, and then we use something called a rule of fourths. So you want to divide that into 4 equal parts. So a half would be pi. Half of between 0 and pi is pi over 2. And then half between pi and 2 pi is 3 pi over 2. And that's going to be our rule of fourths. And then you're going to see that we're going to use our patterns that we discover in the graph to sketch in our graph. So if you need to pause, go ahead and pause that here to get the steps down on graphing, and I'm going to show it in the next couple. So graphing, just basic sine. So if we look at our sine values on our unit circle, again, we talk about the rule of force, and what we really care are what our sine values are at pi over 2, at pi, at 3 pi over 2, and 2 pi. If I made myself a little chart where I call this x and here's y, then my x values, or actually let's call them t values, and y, because that's sine. T is our angle. At pi over 2, I know that sine, actually at 0, and then pi over 2, here's our 4 parts. At 0, sine is 0. At pi over 2, it's 1. Back down at pi, it's 0. At 3 pi over 2, it's -1. And at 2 pi, we're back at 0. This gives us a specific pattern for sine that we're always going to graph. So the pattern for sine is 0, max, 0, min, 0. So you want to remember that because the pattern for cosine is different. So 0, max, 0, min, 0. So graphing basic sine using our 4 main areas that I have labeled here, we're going to start and we're going to put a point at 0 at 0. Then at pi over 2, we go up to our max value, which is 1, because this is our parent function. It hasn't been stretched or compressed. At pi, we go back down to 0. At 3 pi over 2, we go down to our minimum. And then at 2 pi, we're back up at 0. Then our final step is to go through and sketch in a nice curve. So we come through our max, we come down through our 0, go down to our minimum, and back up to 0, and we get a nice sine graph. Right. We're going to take a moment now. We're going to look at those characteristics of sine. So make sure you have this written down. So you might want to pause before we go to the next slide. We want to look at the important characteristics of sine. So you're referring to your sketch graph. What is the domain? The domain is all real numbers. This sinusoidal graph goes on forever. It's just that we do notice we complete one full cycle in 2 pi, but then you just keep going and it goes on forever, both positive and negative direction. Now the range is between -1 and 1. We're going to skip talking about symmetry right now. Our zeros are every pi, 0, pi, 2 pi. So we could say it's really some 0 plus pi is another way to write it. Our period is 2 pi. Our minimum value is -1, and our maximum value is 1. And then a little harder are areas of increasing or decreasing. So we know our intervals of increasing on this specific graph is going to be 0 to pi over 2. So remember, we increase up to here. Now we have a big long decrease, and then starting at 3 pi over 2 up to 2 pi, we go up again. So 3 pi over 2 up to 2 pi. So that is our characteristics of sine only from 0 to 2 pi. If we had a continuous graph, some of these might change. Okay, so these are our increasing values. We want to talk about our decreasing values, which is going to be between pi over 2 and 3 pi over 2. All right, so make sure you get this before we go on to cosine. We're going to have two different videos. One to just talk about our basic graphs, that's this one, and then a shorter video to look at some transformations with amplitude and shifting our graph up and down. Right. So now we have cosine. And knowing that cosine, if we look at our unit circle, T is, they refer to it sometimes in our book as time period. It's also our angle. The same rule of force that we used before. We know that our x values, which is cosine, around our unit circle at 0 is -1. Then I go down to 0. At pi, or sorry, not -1, that's +1. At pi, we're at -1. Then at 3 pi over 2, we're at 0. Then at 2 pi, I'm back up at +1. Those values just came from the unit circle. So here's our pattern for cosine. Our pattern is max, 0, min, 0, max. And I'll talk about these patterns a lot. So notice here they are side by side. Notice sine is 0, max, 0, min, 0. But cosine is max, 0, min, 0, max. So what does that look like? Well, when we go to graph, here's my max point. I come down to 0. I come down to my minimum, back up to 0, and back up to max. And then I fill that in with a nice curve. Yours is probably nicer than mine. There's my curve. Not very great. It's not so symmetric. Make sure you have this before we go. We're going to talk about on the next slide all the characteristics of cosine. So characteristics of cosine between 0 and 2 pi. What's the domain? Still all real numbers. There's a lot that's the same between cosine and sine because they're related to each other. The range is still between -1 and 1. We're still not talking symmetry. Now my zeros this time, my zeros are at pi over 2 and 3 pi over 2. The period is still 2 pi. That's enough to complete one cycle. I start at max and I end up at max. So that's what one cycle is. Where you start, you end up. My minimum value is still -1. My max value is +1. And I start out decreasing on this one. I decrease for the first half. So go down between 0 and pi. And then the last half, I increase. So my increasing is going to be between pi and 2 pi. All right. That's the end of this video. So please come back for the next video where we look at graphing some transformations, which will help you with tonight's homework.